Hello everyone, today I am going to present the topic conic section with the help of GeoGebra. This is an art integrated project in which we integrate conic sections with art. In this video we learn the following. First is the different types of conic sections like circle, parabola, ellipse and hyperbola. Second is mathematical equations of different conic sections. Third is the art of drawing the conic sections by using GeoGebra. Next is giving different colors to different shapes. Last is integrating all conic sections with the art. Conic sections are the sections of cone. These are mainly of four types. First is circle. Its general equation is x minus h whole square plus y minus k whole square equal to r square. The second is parabola and its general equation is y square equal to 4ax. Third is ellipse and its general equation is x square over a square plus y square over b square equal to 1. And the last one is hyperbola and its general equation is x square over a square minus y square over b square equal to 1. Now, with the help of all these mathematical equations, we make a smiley face on the GeoGebra, and this smiley face directly integrate all the conic sections with the art. At the end of this project, we got such type of smiley face on the GeoGebra. This smiley face directly integrate all the conic sections like circle, ellipse, hyperbola and parabola with the art. So this is called an art integrated project on conic section. In order to complete this project, students should know some mathematical equations of conic sections like circle, parabola, ellipse and hyperbola. Along with this, students should also know the use of GeoGebra. Mathematical equations which are used to make the smiley are given here. The first equation is the equation of circle and it makes the face of the smiley. Next two equations are the equations of circle and these two equations collectively make the iris of the eyeballs. Next two equations are the equations of ellipse and these two equations makes the eyeball of the smiley. Next equation is the parabola and the next to this is the equation of straight line and these two equations collectively make the lips of the smiley. And the next equation is the equation of parabola and this equation makes the nose of the smiley, and the last equation is the hyperbola and this hyperbolic equation is used to make the ear of the smiley. Now let us start making the smiley face. When we open the GeoGebra app, then such type of interface we see there, and this is graphical area and this is the input area. Here we can write any mathematical equation and this is the place where we get the graph of related to that mathematical equation. First of all, we write the equation of circle in the input area and we get the related circle here in the graph. So this circle makes the face of the smiley. After making the circular boundary for the smiley face, we again in the input area we write two more equations of circle. These two equations of circle give us two smaller circle and these two smaller circles make the iris of the eyeball. Now we want to make the eyeballs, and in order to make the eyeballs we write two more equations. That equations are the equations of ellipse because the eyeballs looks like a ellipse. So with the help of equation of ellipse we make these two elliptical eyeballs. These are the lips of the smiley face. This lower part is the parabolic and this is a straight line. So in order to make the lips we also need two equations. One is the equation of a parabola and other is the equation of a straight line. In the input area we write two equations. One is parabolic equation and other is equation of straight line to make these lips. Nose of the smiley face is also parabolic. So in order to make the nose we also need an equation of a parabola. So in the input area we again write the equation of parabola according to the requirement and we make the nose of the smiley face. These are the ears. This arc represent the ear, and this arc is also represent the ear. These two arcs represent the hyperbola. So in order to make the ear of the smiley face, we also need the hyperbolic equation. So in the input area, we write the hyperbolic equation and make the ear of the smiley face. These are the ears. This arc represent the ear, and this arc is also represent the ear. These two arcs represent the hyperbola. So in order to make the ear of the smiley face, we also need the hyperbolic equation. So in the input area, we write the hyperbolic equation and make the ear of the smiley face. Smiley face can be made more clear by removing the grid lines and the axes. And if we want to remove the grid lines, then we click here, and if we want to remove the axis, then we click here. And when we remove the grid lines and the axis, then the smiley face become more clear like this. In order to make the smiley face more attractive, we can change its color and give different color to this smiley face. In order to change the color of the smiley face, we click on the graph area and then right click there and then select the color from the option given there, and we can provide different color to the smiley face, and different smiley faces make this activity more attractive and interesting for the students. With the help of mathematical equations and with the use of GeoGebra, we get a complete smiley face which involves all the conic sections. We can also make this smiley face more attractive by giving the different color to the different parts of the face. For example, for the eyes, we can give different color. For the iris, we can give different colors. And for the ears, we can give different color. And for the lips, we can give different color, so that it becomes more attractive and interesting for the students. Now we see that with the help of different color combinations, the smiley face become more interesting and attractive for the students, and each component of this smiley face explain the conic section. See here, the boundary of the smiley face represent the circle, iris represent the circle, eyeball represent the ellipse, ear represent the hyperbola, nose represent the parabola, and the lips also represent the parabola. With the help of this project work, the mathematical learning can be made easy and interesting for the students. So I hope you really enjoy this activity and learn a lot. Thanks and have a nice day.